Hello guys, day 17. This one took me a while, longer than day 18, so that's why the video's coming late. For everyone keeping track, I know there's lots of you. So in this question, pretty much you start in the top left. I might just go to parts 1 and 2 together because my solution is almost identical for both of them. It uses 90% of the same code. So in part 1, you start in the top left, but you have to exclude the top left cell for some reason. And pretty much it's a graph traversal. You're trying to get to the bottom right, and every time you traverse to a square, you add the value of the square to your current total, and you're trying to get to the end, bottom right, with the minimum score possible. And the caveat in the first part is that you can only move up to a maximum of 3 blocks in the same direction until you have to, go into a different direction. So if you go this way 3, you can't go right again. You have to go down in this case. And then I'll explain question part 2 because as I said, my solutions are pretty much the same. So in part 2, it's the same thing, except now you can go up to a maximum of 10 in a row in the same direction. However, you also have to go in a minimum of at least 4 in a row of the same direction. So every time you make a move, it has to be between 4 and 10 in the same direction before you change direction. Okay, let's look at the solution. So you can see both of these use this getAnswer function, which takes the input array, and then it takes a consecutive maximum, so the most amount of moves you can go in a row before you have to change. And this one takes optional consecutive minimum, which is the minimum amount of moves you have to make before you're allowed to change direction. Okay, let's take a look at this getAnswer function. This is where the meat and potatoes happens. So the first thing you do is we have this visited map, which I guess it could have been a set. I didn't end up using this, but pretty much this just keeps track of all the places we've been. It keeps track of the state of each location. So if we get to a point and we've been there before, going in the same direction and with the same length of streak, we know that there's no point repeating that calculation because we've already done it. So this visited array exists so that later on we can check if we've already, you can see here, if we've already had that state, we just continue on and don't add any more nodes to the queue. Otherwise, we have this isValid function. This just checks whether the row and column is inside of the grid. If it's outside of the grid, it will return false. And then here's my priority queue. So with this priority queue, what happens is that we take in a node object and we compare the score of 2 different nodes. So what this function means is that pretty much if the value is negative, that means score 2 is larger. If the value is positive, that means score 1 is larger. And if it's either negative, neutral, or positive, that would decide the sorting algorithm. So yeah, because this number here, say for example, node 1 is -5 and node 2 is 10, that would give a score of -15, and then from that we can determine that node 1 is a smaller value, and therefore we put it higher in the priority. So this is where the queue starts. I just add the first 2 starting nodes. I didn't put in because the 0, 0 in the question statement, it says that this position 0, 0 here isn't added to your score. I just started at 0, 1 and 1, 0. I can't highlight it. But then here, what I did was I just went through this queue, and while it's not empty, I pretty much check the current node, add the current square's score to the score of the current node, and then I check, are we at the end coordinate? If we are, we check if it's the best answer so far. Otherwise, we go through the directions. And here I have these gross if statements, but pretty much the first thing we check is the current direction going in the same direction as we were before, and we've reached the maximum amount of times we can go in this direction. If so, we continue. Then I checked, so because the car, it can't turn around, so I made a map here called opposite direction, which pretty much just maps it to the opposite direction. That's probably a better way of doing that, like negating everything inside it or something. But anyway, we check if it's going in opposite direction, then we also continue because it's not an accepted direction. Then we check if the consecutive minimum isn't null, so if we set it, which we do in part 2, and the streak right now is below the consecutive minimum, that means we have to ignore every direction that isn't going in the same direction, because we're only allowed to keep going in one direction. Then I have these new rows and coordinates, a new row and column, which represents the next point in the queue we're testing out. We're going to see, is it valid, which is the function before, to check if its coordinates are in the range. If so, we make a new node, add it to the queue, and yeah, insert the state into the visited so we don't recalculate this node again, and add it to the queue. Then at the end, when the queue is empty, we just return the answer. Thanks for watching.